Hi guys, my name is Vivek and in this video tutorial I am going to explain what are star and snowflake schema in data warehousing. If you don't know what exactly data warehousing is, I'll highly recommend that you go back, and I have a different video where I've explained in very basic words what is data warehousing, what is fact, what is dimension. I highly recommend that you go back, look at that video and then come back and look at this video. You'll be able to appreciate this video in a better manner. So without doing any further delay, let's go ahead and understand what is star and snowflake schema, in which condition we should use star, in which case we should use snowflake, and that kind of stuff. So let's just quickly refresh our memory and let's understand what are facts and what are dimensions. The whole concept of data warehousing and OLAP system is analysis of data and derivation of meaningful information. So fact are those tables that actually hold the data that is to be analyzed for meaningful information. So consider a situation, I want to analyze, I opened a new office in New Jersey. The office has 5 employees. I want to see what is the kind of business that I'm getting thanks to that office, that kind of stuff. So I can go ahead and see my transaction table, the employees, the kind of products that they have sold in the last month, and what is the revenue that they have generated, whether the revenue actually exceeds their salary and expenses. That will indicate whether I'm having profit or loss, that kind of stuff. So it basically constitutes of two major attributes or columns: the foreign key of dimensions. So fact table is it's also defined as a centralized table in a star schema that is surrounded by the dimension table. So all the primary key of these dimension act as foreign keys, and that defines the grain of the fact table. Grain of the fact table is very important. It's how you uniquely identify a row in fact table. Then we have bunch of major columns which actually give us the meaningful information. So for an e-commerce website, the price of a product is a measure, the quantity that is being sold is a measure, and that kind of stuff. Now what is a dimension table? Dimension table actually contains the descriptive measures which make the facts meaningful. So these are the so for example, fact tables, they only have the keys of the dimension tables. Our dimension tables, like employee, they have the details of the employee, where it resides, what is the office that he belongs to, and all those details, what's his phone number, in which team he works. There are two words that you will hear synonymous to dimension tables, and that those are slice and dice. So as I gave you a previous example, that we want to understand whether the new office that we opened is giving us profit or loss. So we need to slice the data. We need to actually, we know the office name, we opened the office in New York. Now we will use the office code to identify the employees associated with that office, and that we will join with the fact table to get the data. So that's slicing, like filtering the data. You're filtering the data. That's one usage of dimension table. And the other usage is dicing, which is aggregation of data or cubing of data. So my manager, he wants to see for a particular state, what's the revenue generated each month. So I'm aggregating all the policies or all the products that have been sold in a particular month in that state. So that is being done with the help of the dimension table. So facts and dimension table, they go hand in hand in data warehousing. Let's understand what a star schema is. The very simple, if I have to explain that in one word, it's a fact table, or it's a multiple fact. Let's take the example of a single fact table. It's a fact table that's surrounded by dimension tables. The dimensions are in denormalized form. That means we will have a lot of data redundancy, and this can actually sometimes cause data integrity and storage issues as well. So as we have done in our other videos, we are going to understand this with the help of a real scenario. So recently certain e-commerce websites popped up in India, and they said that we will deliver your essential stuff within 2 hours of your order, which is pretty cool, right? But how this will be managed in the backend, that is what we are going to see now. So this is how your star schema is going to look like. You have 4 dimension tables: customers, employee, there is a time dimension, and then there is a product vendor table. So these are the 4 dimensions, and as I told you, the fact table, it actually has 2 main attributes: the foreign key which are the primary key of the dimension tables, the time ID, the product vendor ID, the employee ID, the customer ID, and then bunch of measures on which we can do our computation. So these are either additive or semi-additive measures, and we can do bunch of calculations. Like my manager, he wants to see for the last 7 days how much was the revenue generated each hour, so that he wants to see he wants to increase his employee strength, but he wants to hire some temporary employees, but he only wants to hire for those particular hours where the business is high, the amount of order is high. So what he will do is he will join it with the time dimension. He will do a group by and calculate the amount, and he will identify that okay, over the last 7 days I see that my business is higher during 6 p.m. to 10 p.m. possibly because people are getting back from home, and that's when they order and they are planning or preparing for dinner. So that's a crunch or a crux time for me. I'll go ahead and hire few temporary employees. So these kind of information can be extracted with the help of these. The essential things to remember in star schema is that the fact table or transaction table, it's surrounded by dimension table. It contains the primary key of all the dimension tables. Our dimension tables are descriptive. Like the customer, it contains the customer ID, the name, address, phone number, email, Siri, that kind of stuff. The time dimension, it will have a single record for every hour. Like right now it's maybe 9 p.m. so it will have a 9 p.m., then 10 p.m., 11 p.m. and that kind of stuff. Then it will have a product table. Now the product that the website is selling, it will have the information on that, and these products can be sold by multiple vendors. For example, a camera, Sony can sell it directly. Then there is a local agency, it has the advantage that its shipping cost will be low, so that can sell it. Then there is a huge warehouse that is selling that camera. So there can be multiple vendors selling the same product. So we will have certain redundancy of data here, and the key will be product ID and the vendor ID. Let's go ahead and see how our data will look like. So this is our product and vendor table. Here the product ID is 1. The LED TV with model number 234 is sold by vendor 1, 2 and 3. These are the vendor names. Obviously they are dummy names. They lived at different streets. Their phone number is this. So a particular product, be it LED TV or camera, it can be sold by multiple vendors. Now the challenge here is, if you see, we are repeating the information of this vendor. So vendor 1 has the same vendor number, the same address, the same phone number. I have not displayed it right now, but we are repeating certain details. So that indicates that this dimension table is not normalized, it's denormalized. The advantage that I gain here is that my joins are simpler. If I have to get some information pertaining to a vendor ABC, I can directly join it with my transaction table and get the data. Let's look at our second table, which is our employee table. Now these are the employees that are working. Vivek, Richa, Roger, they have certain information, the address that they live in, the phone number, the email, the salary, the office that they belong to. Then we have our customer table. So we have a bunch of customers. We have their address, we have their phone number, the email, the city. Now here the challenge you see is all these details are repeated again and again. The city, the state, the zip code, and USA. Now consider my website is going very popular. My business is expanding. I have 2 million people who are buying products from Houston, 2 million people from Dallas. 2 million will be a little high. Maybe like say 50,000 people from each of these cities are buying my product. So I'm repeating their details in my customer table. So my table is denormalized, but at the same time my join is easy. So the thing in star schema is that your tables are denormalized. What we have learned by now, the tables are denormalized, the joins are easy, we have redundancy, because of which we are having a data storage issue, and sometimes we can have data integrity issue as well when we try to update certain data, because let's say by mistake I placed or the zip code of Houston was incorrect. Now I'll have to go ahead and modify that zip code in 2 million rows. So that can lead to certain issues. This is our time dimensions. So maybe the denormalized concept you can understand with this clearly. For every hour in a day, we are getting a row. So for each days, we will have 24 rows with unique ID. So the hour is 7, the date is this, and then the day is Wednesday today. The date is 27, the month is September, the code is Q3, and the year is 2017. So we are repeating this information a lot of time. Like these two columns, date and day, they are repeated 24 times. Same with this column. This is repeated even more. So there is a lot of redundancy. But again, if I have to see the sales, I don't have to join with the third table for the year 2017. I can just directly join this table with my transaction table based on the date, and I can retrieve my data. So if we quickly recap what we have learned for star schema is, the fact table is surrounded by a bunch of dimension tables. It has foreign keys of all the dimension tables with a bunch of measures. The dimension tables are denormalized, because of which they are redundant. They carry redundant data like here, and as we discussed in the example of our customer table, if we make a mistake, this can lead to data integrity issues, or something has changed. We will discuss that in in another video, the concept of slowly changing dimensions that can actually lead to data integrity issues. So let's go ahead and understand the snowflake schema first and how it is different from the star schema. So the only difference between star and snowflake schema is that the dimensions in snowflake schema are normalized. The facts are the same. I'll not touch my fact table. It's going to be exactly the same, but my dimensions will be normalized. And now that I have normalized my dimension, it's going to reduce my data storage, and it's going to resolve my integrity issues. But since we have additional tables in place now, it's going to increase my join complexity to retrieve the data. And since we will be joining more tables, the time taken to get the data, or the time taken to query the tables, it may increase. Let's see what I'm talking about. So this is how a snowflake schema looks like. This transaction table is our fact table. If you see, nothing has changed. It's the same kind of table. Nothing has changed here. But what we have done here is we have denormalized some of our dimension tables, like time dimension. Now we have broken this time dimension into two tables. The first table is time dimension and the second is date dimension. Now date dimension has a single record for every date, which means we have reduced the data. Similarly for city, similarly we saw for customers, as I told you that there is a possibility that for each city I may have 50,000 customers and their city ID or city name, zip code and country, it will be same. So once we denormalize it, it's going to reduce the data it was being taken, and we will see it how. The same goes for product vendor table as well. Earlier we had the vendor information was being repeated on a constant basis, and let's assume that a particular product which is very popular is being sold by thousands of vendors. In that case, maintaining that or having that kind of redundant data, it's going to be very complex. In real world time dimension, you will see a lot of places where you actually normalize the time dimension. If you work for financial institution, they have huge number of products, you will see that they will denormalize that. At some places you can actually see this product and vendor information denormalized as well. So there are cases where Snowflake schema is actually used, the dimensions are denormalized. Let's just quickly recap what we learned till now. The fact table here stays the same, but the dimension table or the dimension tables are denormalized. This actually improves the data storage, it reduces the data storage. At the same time, it improves the data integrity, because now you have to update only one column or not as many columns when the data was denormalized. And the challenge here is that in case if I want to retrieve the details for vendor name ABC, now the join complexity has increased, because the vendor, I'll have to join the vendor table to the product vendor table and then the transaction table. So earlier where I was joining just 2 tables, now I'll have to join more than 2 tables. And let's assume that I want to get the data for a particular day. That further increases my complexity for that particular vendor, because I'll have to join the date dimension with the time dimension, and then I'll have to join with the transaction. So the number of joins is increasing constantly, and which brings additional complexity, and in certain cases time delays as well if your Snowflake schema is not designed well. Let's go ahead and see the data, how it looks like after the dimensions are normalized. This is my time and date dimension. So I still have a single row for every hour for this particular date, but these columns which were getting repeated, I was having Wednesday 24 times, the date 24 times, the month 24 times. That issue has been resolved now. Now I have a single row for each date here. So that means it gave me an advantage. The data storage has been reduced to almost maybe like 80%. It has improved. So that is a huge number. Let's see about product. Again, with product I had multiple information being repeated. Now that's not the case. I'm just repeating the vendor ID, and in case if I require the detail of vendor ABC, obviously I'll have to join the vendor table now with the product vendor table and then the transaction table, which means added complexity. But at the same time, the data storage problem, it has been resolved. That's the example of customer and city. So here again, if I have 50,000 records for Houston, I don't have to repeat all this information. And if by mistake there is, or the zip code changed or something changed, or I made a mistake, I just have to update a single row and the entire thing will be taken care of. So it actually resolved my data storage issue. It actually resolved my data integrity issue. But at the same time, it introduced the complexity of more and more joins and possibly a time delay as well because of the additional joins. So that's the final question now. We have certain advantages of star schema, we have certain advantages with snowflake schema. Which should we choose in which scenarios? The very simple thing is, the very simple question, if I have to explain that in one line, if your facts constitute majority of the data in your warehouse, go ahead with the star schema. If your dimension size are huge, like we discussed in case of our time dimension, or you have a number of products in that case, or you have a lot of attributes for that particular products that are being redundant, in that case you may want to go ahead and use the snowflake schema. Let's discuss the characteristics. Let's just quickly recap them again. So the star schema is denormalized while the snowflake is normalized. Because the star schema is denormalized, that means we have redundancy, which consumes more storage space. The advantage that we gain from here is that the joins are simple and we will have faster performance. But as we discussed that because of this, we actually may run into some data integrity issues. The snowflake schema, since they are normalized, they take low storage, but because of that, since we are dividing into more and more tables, it can result into complex and multiple joins. This can actually slow our queries, and we may run into performance issues. So usually in reality, you will have hybrid schemas for big warehouse. If it's a mart and majority of your data is constituted or framed by fact table, go ahead and use star schema. If your dimensions are huge, like they are taking a lot of space, you should go ahead and think about denormalizing them. So that is all about this video. I hope now you understand what is star schema, what is snowflake schema, and you will be able to identify them easily in a warehouse. And in case if somebody asks that in which case you should implement star schema and in which case you should implement snowflake, you will be able to answer that in a better fashion. Thanks a lot guys for watching this video. In case if you have any questions, go ahead and specify them in the comment sections and I'll try to reply to you guys as soon as possible. Also, please like my video. It actually helps me and encourages me to make more and more of them, and subscribe to my channel so that you are updated with all the new cool videos that I make. Thanks a lot guys.